Hello, my dear students. Today we are going to continue our discussion on chapter 2, which is chemical analysis. We are going to discuss the last part of quantitative analysis. We are going to discuss the gravimetric analysis, and we are going to discuss some problems about it. So let us start. Gravimetric analysis. It is the method depends on the separation and determination of the mass of analyte. Then, by using chemical calculation, the quantity of the analyte can be measured. Now we are going to discuss the methods of separation. Volatilization method. It is based on volatilization by warming the solution or igniting the element or the compound to be determined. The methods of measuring the mass of the element or the compound either by collecting the volatile material and determining its mass, or measuring the amount of loss that from the original mass of the substance. For example, a sample of hydrated barium chloride BaCl2.xH2O with a mass 2.6903 gram is heated. Its mass became 2.2923 gram. Calculate the percentage of the crystallized water, then determine the value of X in the hydrated barium chloride and write its molecular formula, where the atomic mass of oxygen equals 16, atomic mass of hydrogen equal 1, atomic mass of chlorine equals 35.5, and atomic mass of barium equal 137. Solution. The mass of water equal 2.6903 minus 2.2923 equals 0.398 gram. So the percentage of crystallized water equals 0.398 times 100 over 2.6903. So equal 14.79%. Now 2.2923 gram barium chloride gives 0.398 gram water. So 137 plus 2 times 35.5 equal to 108 gram barium chloride gives X gram water. So the mass of crystallized water equal 208 times 0.398 over 2.923 equals 36.114 gram. So number of moles of water, mass of water over its molar mass. So 36.114 over 18 equals 2.006 moles, approximately 2 moles. So the molecular formula of hydrated barium chloride is BaCl2.2H2O. Now we are going to discuss the second method, which is precipitation method. It is based on the precipitation of the analyte in the form of pure sparingly soluble compound with constant and known chemical structure. The steps for measuring the mass of the precipitated compound. By filtration on an ashless filter paper, the precipitate is isolated from the solution. Transferring the filter paper with the precipitate to an ignition crucible and completely ignited until volatilization of the constituents of the filter paper. Weigh the mass of the precipitate remains after ignition and use it to determine the mass of the analyte. So we have give reason in this point. Ashless filter paper is used in the chemical analysis by precipitation method because it leaves no ashes on ignition. For example, sodium sulfate solution is added to barium chloride until complete precipitation of barium sulfate. Then after fertilization and drying it, the mass of barium sulfate is 2 grams. Calculate the mass of the barium chloride in the solution. Here, the atomic mass of oxygen equals 16, sulfur equals 23, chlorine equals 35.5, and barium equal 137. So the solution here, as the equation proceeds on the screen, barium chloride plus sodium sulfate, BaCl2 plus Na2SO4 gives BaSO4 plus 2 NaCl. So the relation between the barium chloride and the precipitate, 1 mole of barium chloride precipitate 1 mole of barium sulfate. So the molar mass here of barium chloride 137 plus 2 times 35.5 equal 208 gram barium chloride. And it gives 1 mole of barium sulfate, its molar mass 137 plus 23 plus 4 times 16 equal 233 gram of barium sulfate. So x gram of barium chloride gives 2 gram of barium sulfate. So mass of barium chloride equals 208 times 2 over 233 equal 1.785 gram. Mention the mathematical formula relating between the following: the volumes and the concentration of each of acid and alkali at the end point of their titration. Here M1 V1 over Na equal M2 V2 over Nb, where M1 is the concentration of the acid used in mole per liter, V1 is the volume of the acid used in titration in milliliter, and Na is the number of moles of acid from the equation of the reaction. M2 is the concentration of alkali used mole per liter. V2 is the volume of alkali used in titration in milliliter, and Nb is the number of moles of alkali from the equation of the reaction. Now some problems. 0.2 gram sample of impure oxalic acid. Its chemical formula COOH2 reacted with 39.82 milliliter of 0.1023 molar caustic soda. Calculate the percentage of oxalic acid, where the atomic mass of carbon equal 12, oxygen equal 16, hydrogen equal 1. The solution: the number of moles of sodium hydroxide equal concentration times the volume. So equal 0.1023 times 39.82 times 10 to power negative 3 equal 0.004 mole. You must write the balanced chemical equation at first. COOH all 2 plus 2 NaOH gives 2 COONa plus 2 H2O. So 1 mole of oxalic acid reacts with 2 mole of sodium hydroxide. So 2 times 12 plus 2 times 16 plus 1 equals 90 gram gives or reacts with 2 moles of sodium hydroxide. So x gram reacts with 0.04 moles. So mass of oxalic acid equals 0.004 times 90 over 2 equals 0.18 gram. So percentage of oxalic acid equals 0.18 over 0.2 times 100 equals 90%. Next problem. Find the percentage of impurities in 2 gram ore of zinc oxide that reacted with 30 milliliter hydrochloric acid, where 0.5 liter of hydrochloric acid contains 18.25 gram of pure hydrochloric acid, where the atomic mass of hydrogen equal 1, chlorine equals 35.5, zinc equals 65, and oxygen equals 16. Solution. Here the concentration equal mass over volume times the molar mass. So the concentration of hydrochloric acid equal 18.25 over 0.5 times 1 plus 35.5, so equals 1 molar. So the number of moles of hydrochloric acid equal its concentration times the volume. So 1 times 30 times 10 to the power negative 3 to convert it to liter, so equals 0.03 moles. So you must write the balanced equation at first. Zinc oxide plus 2HCl gives zinc chloride plus water. So 1 mole of zinc oxide reacts with 2 moles of hydrochloric acid. So 1 times 65 plus 16 equal 81 gram of zinc oxide reacts with 2 moles of HCl. So x gram of zinc oxide reacts with 0.3 moles of hydrochloric acid. So the x gram or mass of zinc oxide equals 0.03 times 81 over 2 equal 1.215 gram. So percentage of zinc oxide equal 1.215 over 2 times 100 equals 60.75%. So the percentage of impurities in the ore equal 100 minus 60.75 equals 39.25%. Next problem. In the titration of 25 milliliter of 0.5 molar aqueous hydrochloric acid exactly neutralize 20 milliliter of calcium hydroxide. Find the concentration of calcium hydroxide. Solution. You must write the balanced chemical equation at first. 2HCl plus CaOH2 gives CaCl2 plus 2HCl. So for HCl, hydrochloric acid, concentration equals 0.5 molar. Its volume equals 25 times 10 to the power negative 3 to convert it to liter. And the number of moles in the equation equal 2. For the calcium hydroxide, concentration is unknown. And the volume of calcium hydroxide V2 equal 20 times 10 to the power negative 3. And the number of moles in the equation equal 1. So by applying the relation, M1 V1 over Na equal M2 V2 over Nb. So 0.5 times 25 times 10 to the power negative 3 over 2 equal M2 times 20 times 10 to the power negative 3 over 1. So the concentration of calcium hydroxide M2 equal 0.5 times 25 times 1 over 20 times 2 equal 0.312 mole per liter. Next problem. What is the volume of 0.25 molar K2Cr2O7 must we dilute to prepare 250 milliliter of 0.05 molar? Solution. As the number of moles of K2Cr2O7 is constant, so M1 V1 equal M2 V2. So 0.25 times V1 equals 0.05 times 250. So V1 equal 50 milliliter, so equal 50 over 1000 equal 0.05 liter. Another problem. Mixture from solid substances contains sodium hydroxide and sodium chloride. 0.1 gram from it is titrated by 10 milliliter from 0.1 molar hydrochloric acid. Calculate the percentage of sodium hydroxide in the mixture. Solution. The hydrochloric acid is used to neutralize sodium hydroxide, so HCl plus NaOH gives NaCl plus water. So the number of moles equal concentration times volume, so 0.1 times 10 over 1000, it will be 0.001 mole. So from the equation of the reaction, 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So 0.001 mole of hydrochloric acid reacts with 0.001 mole of sodium hydroxide. So the mass of sodium hydroxide in the mixture equal number of moles times the molar mass. So 0.001 times 23 plus 16 plus 1 equals 0.04 gram. So the percentage of sodium hydroxide in the mixture 0.04 over 0.1 times 100 equal 40%. On oxidation of 0.5 gram of magnetite ore Fe3O4 into iron 3 oxide, 0.411 gram of iron 3 oxide are produced. Calculate the percent of black oxide Fe3O4 in the ore, where the atomic mass of iron equal 56, oxygen equal 16. Solution. Here's the equation of the reaction. When the magnetite ore is oxidized into iron 3 oxide, this iron 3 oxide here, the equation will be balanced as shown on the screen. So means 2 mole of magnetic iron oxide gives 3 mole of iron 3 oxide. So 2 times 3 times 56 plus 4 times 16 equal 464 gram. That gives 3 times 2 times 56 plus 3 times 16 gives 480 gram. So x gram here can be 0.411 gram. So x gram will be 0.411 times 464 over 180 equal 0.3973 gram. So the percentage of iron, magnetic iron oxide, will be 0.397 gram over the mass of the ore, 0.5 times 100, it will be 79.46%. Calculate the percentage of chlorine in 2 gram of impure potassium chloride, which reacts with silver nitrate to get 4.628 gram of silver chloride, where the atomic mass of potassium equals 39, chlorine equals 35.5, and silver equal 108. Here the solution is the balanced equation of the reaction. KCl plus AgNO3 gives AgCl plus KNO3. So 1 mole of potassium chloride gives 1 mole of silver chloride. So 1 times 39 plus 35.5 equals 74.5 gram potassium chloride gives 1 times 108 plus 35.5 equals 143.5 gram silver chloride. So x gram potassium chloride gives 4.628 gram silver chloride. So x equals 4.628 times 474.5 over 143.5 equal 2.4 gram. As we know that 1 mole potassium chloride contains 1 mole chlorine. So 1 times 39 plus 35.5 equals 74.5 gram potassium chloride contain 1 times 35.5, 35.5 gram chloride. So 2.4 gram potassium chloride gives x gram chlorine. So x gram chlorine equal 2.4 times 35.5 over 74.5, it will be 1.14 gram. So percentage of chlorine equal 1.14 over 2 times 100 equal 57%. Find the molarity of a solution where 4 liters of it contain 160 gram of caustic soda, where the atomic mass of sodium equal 23, oxygen equal 16, hydrogen equal 1. Solution. Concentration equal mass over volume times the molar mass. So equal 160 over 4 times 23 plus 16 plus 1, so equal 1 molar. Another problem. Calculate the molarity for a sugar cane solution. Has molecular formula C12H22O11 in water if the mass of the dissolved sugar is 88.5 gram in a solution volume 0.5 liter, where the atomic mass of carbon equal 12, hydrogen equal 1, oxygen equal 16. So the solution here, the molarity equal mass over volume times the molar mass. So 88.5 over 0.5 times 12 times 12 plus 22 plus 11. So it will be 1 molar. Now, my dear students, we are going to discuss some questions. First one, write the scientific term. Molecular mass of substance expressed in grams. Yes, it is mole. It is the number of molecules or atoms or ions in 1 mole of substance, which equals 6.02 times 10 to the power 23. Yes, it is Avogadro's number. It is the volume occupied by 1 mole of any gas at standard temperature and pressure, which equals 22.4 liter. Yes, it will be molar volume. A chemical process by which the concentration of a solution can be determined by using standard solution of known concentration. Yes, if you think about it, yes, it will be titration. It is a solution where each liter contains 1 mole of solute. Yes, the answer, it will be molar solution. Next one, it is the concentration of a solution in moles per liter. If you think about it, yes, it will be molarity or mole per liter. Are used to identify the elements or constituents of the substance. Yes, the answer, it will be qualitative analysis. Are used to calculate the percentage or the concentration of each element in a substance. If you think about it, yes, it will be quantitative analysis. It is the identification of constituents of the substance, if it is pure or mixture. If you think about it, yes, it will be qualitative analysis. It is the determination of the ratio or the percentage of components in the substance or mixture. If you think about it, it will be quantitative analysis. Next point, the branch of chemistry deals with methods and instruments used for identifying the substance. If you think about it, it will be analytical chemistry. Choose the correct answer. The salt solution plus sodium hydroxide solution produce reddish brown precipitate of what? Is it calcium, iron 3, aluminum, or iron 2? If you think about the answer, here's the answer, it will be iron 3. Next one, salt solution plus sodium hydroxide solution produce white green precipitate of what? Is it iron 2, aluminum, calcium, iron 3? If you think about it, yes, it will be iron 2. Next one, salt solution plus dilute hydrochloric acid and hydrogen sulfide gas giving black precipitate of what? Is it calcium, iron 2, iron 3, copper? Yes, it will be copper. Next question, salt solution plus sodium hydroxide solution produce white gelatinous precipitate of what? Is it calcium or iron 2 or iron 3 or aluminum? Yes, if you think about it, yes, it will be aluminum. Next one, salt solution plus ammonium hydroxide solution produce reddish brown precipitate of what? Is it calcium, iron 3, aluminum, iron 2? If you think about it, yes, it will be iron 3. Next one, the salt solution plus ammonium hydroxide solution produce white green precipitate of what? Is it iron 2, aluminum, calcium, iron 3? If you think about it, yes, it will be iron 2. Next one, salt solution plus ammonium hydroxide solution produce white gelatinous precipitate of what? Is it calcium, iron 2, iron 3, aluminum? If you think about it, yes, it will be aluminum. Salt solution plus silver nitrate solution, it produces yellow precipitate that insoluble in concentrated ammonia solution. Is it iodide salt or nitrate salt or chloride salt or bromide salt? If you think about it, my dear student, yes, it will be iodide salt. Another new question. Mention mathematical formula relating between each two of the following. The number of moles of a gas and its volume at a standard temperature and pressure. Yes, the answer is volume in liter equal number of moles times 22.4. Next one, the molecular mass of the gas and its density. Yes, the answer it will be molecular mass equal density times 22.4. Next one, the concentration of the solution and both the number of dissolved moles and the solution volume. Yes, the number of moles equal concentration times the volume. Next one, the number of produced ions in the solution of totally ionizable substance and the number of its dissolved moles. If you think about it, yes, the answer it will be number of ions equals the number of moles times 6.02 times 10 to the power 23. My dear students, we have reached to the end of our program today. I hope you understood all the points and the problems that we discussed today. So till we meet again, my best wishes for you.